Hello everyone, this is Dr. Wu. I'm going to demonstrate for the lab this week. It's called Refraction of Light. So here is the lab instruction. So you can use it and get the result and answer the questions. So let's go to Beyond Labs and click the Open in Physics. It takes a few, maybe 10 seconds to get to the. So when you open the worksheets, find the lab under optical waves. So that's the refraction of light. Yeah. Once you click that button, then you will get to this lab bench, and this one is the laser to generate the light with a wavelength of 600 nanometer, and this prism, the two parts. You can see the light go through from here and get to the certain angle out. So now you can answer the first this question. So pre-lab question. It's called, does light move faster, slower, or at the same speed when it travels through from air into glass? Explain. So let's say this prism is made of glass, and the light travels slower in the glass because more particles get in its way. So that's the answer for the first question. Then, if we look at the procedure, section 1, then we will see this observe the light from the first prism and answer question 1 to 7. So the question 1 asks why does the path of light bend as it enters the first prism? Is it bending towards or away from norm to the surface? Draw the light and path, the light path and the normal on this the diagram on the left, on the right side. So the answer is the light bends because it slows down and the wavelength decrease in glass, so it bends toward the norm. So norm is here perpendicular to the surface one edge when the incident occurs. So it's this one. Based on the first section, then we can answer question number 2 as well. So which way does the light bend as it exists? The first, the prism, is it bend towards or away normal? Draw the existing beam and the normal on your diagram in question 1. So if you get that instruction, you will see there's a triangle there, referent prism. You can draw the picture. So the answer is the light bends away from norm as it exists in prism. So you can see when we draw this light, it shows like this. So that's the incident light. Then this one is the one that's called norm, and the angle. So yeah, that's another angle. Once it gets away from the prism, so the light band further away from norm. So now we can move to question number 3. Based on your observation and the Snell's law, is the index of a refraction of the prism greater or less than the index of refraction of air? Explain your answer. So this index of a refraction of the prism is greater than the index of air, because they are in this different substance. So now we can do the next part of the experiment and to answer question number 4 to 5. So let's bring the second prism here, and you will see this the light bands again then parallel to the first incident light. So when it out from the second prism. So now we can answer the question number 4 and 5. What do you notice about angles of a refraction in the second prism? Does the light bend in the same way that it did in the first prism? So the second prism appears to have the same index of a refraction as the first one, because the prism are made the same material, and just the two mediate involved. One is air, another is this glass prism. So number 6, describe the path of light through the second prism. Does anything surprise you in the light path? How does the orientation of the prism affect the path of light? So the second prism is rotate, you can see here, and does not have the same orientation as the first one. So that's the one here. Then this is the second. So the light ends up existing in a path parallel to the original one. The original is over here. Then when the light out of the second one, so here, even though they are not at the same this path, but their paths are parallel. It's not the exact same, but they are parallel. So that's the question number 6. And question number 7 says this: how does the index reflection of the second set of prism compared to the first two prism. How can you tell? So the second one has the same index refraction as the first one because the light ends up directly parallel with the first, with this original beam. So then question number 8, how does the distance between the prisms affect the reflection angle? So we can adjust the distance by push it back, so make it small distance or large, then small distance and large. Then from this change, you can see when the prisms are further apart, the angle of the reflection does not change, but the light can travel at the same angle. So the prism need to be separate out at a certain angle. Then question number 9, how does this wavelength of laser affect the reflection of angles? So we can change this. You can see the change, the parts. So if you click that dial, then now the wavelength 600. Let's get this. Let's say 450 nanometers. Okay, 450. So it's a blue light. You can see this one. It has the lower frequency bands at a great angle. So you can see the angle gets large. So that's this one. If you want to see the one compared to 600 nanometer, you can see, yes, they are smaller this angle. So we finished the first section, and now we move to procedure section 2. So the click and drag the laser source back and bring the light source here. Now we see the different image. So the light snap go through the first prism and the second. Now we can answer the question number 10. So what is the difference about angles of a refraction of a different color of light as compared to the one wavelength laser light? So for this, the regular light, the light consists of different colors of light. So you can see how each color of light bends at different angle. The right and green, this is green and blue. Question number 11. Does the index of refraction of a piece of glass depend on the wavelength of the light passing through it, and why? So the index of refraction depends on the wavelength of the light passing through it. This is how every wavelength can bend differently in the same glass. Number 12, which color of light has the greatest angle of refraction? Which wavelength has the greatest index of refraction? The answer is violet has the greatest angle or refraction. The blue or violet range about 400 nanometers had the greatest angle of refraction. Question 13. Based on Snell's law, why does each color of light bend at a different angle? The reflective index depends on the wavelength of light, so the angle at which each color of light reflects will be different. Then question number 14. So what does the experiment prove about the components of the white light? So this experiment proved that white light is made of different wavelengths of light. Different color of light are dispersed when passing through the prism. Then the next question, question 15. What would happen if block off some of the colors of light before they re-enter the second prism? Okay, block off. Let's see how to block. Yeah, if you block off the color of light from the combination, the light will not form white light again. It would missing some components of wavelength. So if we block off some, then you will not get this the white light. So that's this experiment, and you can watch it again and complete all the questions. Thank you. Bye-bye.